Hey guys, we are looking at number 4 off of our homework. We should have gone home with at least number 1 and number 2 already done, so those are really good examples to look back at if you forgot what to do. Plus, we're getting ready to do number 4. So today in class we've been discussing area models and using area models to multiply decimal problems. Okay, so our problem says Lucy and Lola Longlegs are best friends. They are both very pretty as well. Today they lay next to 3 different lilies. Each lily was 6 and 6/10 centimeters tall. How tall were the lilies combined? So obviously this is a multiplication problem where we are supposed to multiply 6 and 6/10 times 3. Now in class we also talked about how important it is that we estimate first, just to make sure that when we're done multiplying, our answer at least makes sense. It should be really close to our estimate. So first, we're going to write our problem down, which is 6 and 6/10 times 3. Now we're going to estimate. If this were money, 6 and 6/10 is really $6.60. So that's pretty close to having $7. Remember when we estimate, we use the easy numbers that are easy to count by, easier to work with, compatible numbers, okay? Times 3. 7 times 3 is 21. That means when I'm done with my area model and I multiply, my answer should be somewhere close to 21. If we get something crazy like 213, we'll know we're off somewhere because our answer should be really close to 21. Okay, so I'm going to draw my area model. And today in class we talked about area being length times width. So we looked at length in the direction that length travels. Length travels from side to side, left to right, horizontal. We also talked about the length, the direction that width travels in, and that is up and down, vertical, top to bottom. So here's my length, and here's my width. So for the purposes of this problem, I'm going to say that my length is going to be 6 and 6/10. That was this number in my problem. This number in my problem. For the purposes of this problem, I'm going to say my width is 3. This number of my problem, this number of my problem. So if I were a carpenter and I were trying to measure my classroom, and I'm starting in this corner and I'm going over horizontal, I need to measure across 6 and 6/10. So for my 6 holes, remember those are our big flats from class, and I'm going to draw that. Each one of these represents a hole. 4, here's 5, here's 6. Now I'm not done because not only do I have to draw 6 holes, which I've done, I'm also going to draw 6/10, which are going to be smaller. So here's 1 10, 2 10, 3 10, 4 10, 5 10s, and 6 10s. So now I'm going to go down for my width, and I'm going to draw 3 in my width. So 1 is already there for me. Here is 2 holes, and here is 3 holes. So I did my job. I drew the length of 6 and 6/10. I drew the width of 3. Now remember, I know if this were a carpenter wanting to put carpet all over to cover my entire classroom, I wouldn't want just carpet in this area only, right? Who wants an L-shaped carpet with a big old patch of cement in the middle? So that means we're going to have to fill in the inside. We also talked about area, meaning the inside. We need to fill in the inside to completely cover my whole classroom. All right, so that means I'm going to have to use some of these same shapes to fill in the inside. So in order to do that, we're going to add some more holes, and we're going to add some more tins, just to make sure the entire classroom is covered with these square units. I'm going to add some more holes because those were our biggest pieces. They covered the most square inches or square units. Now I'm going to use the rest and I'm going to do the exact same thing again, add in some more holes. And I'm going to add some more tins, because that's what we have room for, to fill in the rest. Now, look at that. My whole classroom has been covered. Now, all I'm going to have to do to get my answer is I'm going to just write down what I've got so far. Count my number of holes. So, I'm going to use this highlighter to kind of put a dot inside everything that I'm counting as a hole. So, here's a hole, 2, 3, 4, 5, 6. Those are holes. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So far I know that I have 18 holes. Now I'm going to count up my tenths. Please keep in mind that tenths are called tenths because it takes 10 of the tenths to make a hole. So we may end up swapping out some of our tenths for holes later on. Right now, I'm just going to count them. I'm going to use a different color of the highlighter to show that I'm counting tenths. All right, so here's 1 tenth, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 holes and I have 18 tenths. I'm just going to write that down real quick. 18 holes and 18 tenths. Remember, it takes 10 tenths to make a hole. So I'm going to swap out 10 of these tenths, and I'm going to swap it out for a hole. So here are my 10 tenths. Here's the first. 1, 2, 3, 4, 5, 6. That's 6. 7, 8, 9, 10. I'm going to swap those 10 tenths out. Swap those out. I don't have 18 tenths anymore because I took 10 of them away. Now I only have 8 tenths left. Now remember, those 10 tenths that I took away, they make one big hole because they're about the same size as one big hole. So now I don't have 18 holes anymore. I've got 19. I added one more hole. 19 holes. Alright, so now let's look at what I've got left. I've got 19 holes and 8 tenths. So that's actually our answer. So we're going to come down here in the solution box and we're going to make sure that we put my answer is 19 and 8 tenths lilies. Now let's take a look and see if it's somewhere close to my estimate. My estimate was 21. 19 and 8 tenths is almost 20. So yeah, I'd say we're pretty close. Alright guys, bring any questions that you have back to me tomorrow and we will work on the rest in class. Try to finish this up and then we'll see where we are tomorrow. Have a great night and I will see you guys tomorrow.